Hey, hi everyone. This is Sai from Let's Upgrade. So let's talk about how to get your certificate. It's very simple. You will see two links in the description. Number one is the place where you have to go and mark your attendance. Marking your attendance tells us like, okay, you are a legit student who have attended this particular session. Link number two is your assignment. This is where your 90% of the priority is. You have to go and submit the assignment that is given to you in this particular session. Once you're done submitting that assignment, we will be evaluating that. We will send you an email. If you get the passing criteria, then only we will give you the certificate on a particular date that is mentioned again in the description. Please check these three things, and this is the way how you will get a certificate from Let's Upgrade. Number one, mark your attendance. Number two, just go ahead and upload your assignment. Check for the email that you have received it, yes or no. What is the feedback that you have received from your trainer? Number three, check on which date the certificates will be released. Thank you. Bye. All the best. Happy learning.
So, by the end of this session, you will be understanding what machine learning is, how to prepare data for machine learning, how to build and train a machine learning model, and what it is. Basically, there are many type of machine learning models, and which is to understand, to have that knowledge that this machine learning model will solve my problem, because each problem has its own complexity and each and every model has its own variability or features, we can say. Because there might be the cases where regression model or a double regression model cannot be suitable for a classification or particularly predicting a number, but there might be cases where different clustering models are used for classification. So, depending upon the problem, data scientist has to take the call that what model I should use. And don't worry, it is still, although I have used many models and I have the experience of doing all this thing, I also first try and see what the outputs are. And if the results are too bad and worse in the cases, I just shift to a different model and try that. So this is where the scientist word comes in, where you have to try and fail. And there's a thing where you will be getting the your desired results. But this is the proper way to do the things. Even though when you are developing a LLM models or you are doing some research, it is not the thing that you will understand, or you even I also sometimes learn what the models are, how the feature will work. So there is nothing like that you have to learn once. It's just a phases learning. You have to learn in phases and understand the core concepts. Now, next you will be understanding the evaluation of model, how you evaluate, what are the matrices, and how to basically check that my model is working perfectly or not, at least in the development. At last, we will start with what is machine learning, what it does, why we call it machine learning. So, machine learning is a part of data science where we teach computers how to find the patterns. In this case, at the starting of the computer evolution, people give give them an input and the patterns, and they do the output. Just like you write a small Python program of hello world, just like this: print hello world, hello world. Yeah, just like this. In this case, what you have done, you have given the input and you have explained him. Not in this case like print, because although print has its own working, all we are using the print function, it has been written in the core library of Python, but we have to make him understand that this is the input, this is the method to solve or to evaluate this input, and you have to give the output. But nowadays, what is machine learning? Machine learning is where it comes, yeah, we will, as a user, I will provide the input, I will provide the output. and you have to find or recognize the pattern of that output. This is simple machine learning, where you will give two things, input and output, your basically training and testing part, and it will recognize the pattern. And in when it encounters a new thing, it will try to implement that recognized pattern in that way. Just like our brain, we study, we test ourselves in mock testing, and when the new questions come in examination, we try to implement or recognize all that pattern and try to solve that particular problem. It is the same way. That's why it is called machine learning, and it is very resembles or very inspiring from human brain basically. Next, instead of writing just like the same way, rules are nothing but the patterns, the way to solve a problem or to solve a complex problem. We give them input and output, and it own writes the basically its own writes the rules for it. That's it. Now, just like at the beginning of this boot camp, I told you like the Netflix example, I have given you the Zomato delivery time example, where how Netflix recommends you the movies based on your different watch list or history, and Zomato predicts the timing of delivery by understanding the route and the traffic it encounters. Google Map does the same. Banking, fraud detection, which is also I have given you the example of outlier, where the outlier methodologies are very effective. And it is used in many of the banks. The healthcare, where by image reading or by OpenCV or optical character recognition OCR, we are predicting different diseases. There is a case where AI model has predicted a disease where experienced doctor was not able to recognize that thing. So this is how the human civilization is right now evolving, and it is very in a good way, and there might be bad cases also. So we have to understand the problem and then try to solve it using machine learning. That's it. Now, the machine learning has basically, in a broad way, it has two main types, supervised and unsupervised. Supervised, where we have to give them the input with its labels, like what is the output of that input. That's it. And in unsupervised, we have to give them the input, but not tell what is the output. They have to find the output. They have to categorize the inputs to understand or find the patterns for what we are desired. The basic example which I can give is predict the house price, like at the day two that data set we are using, or predict the student marks you based on their past activities or past history, or predict the salary of a person based on its career growth, its studies and all, place or predict the placement scenario of students, whether they are going to place or not based on the past students or their seniors. These all are supervised learning. In further, supervised learning is also can be break down into two parts, which is regression and classification. Where regression, the outputs, like the prediction output will be always numbers, and in classification their output will be categorical. Like regression, we use regression where we have to predict the numbers, just like the house prices or the student marks, or simple way we can choose is how much a man gonna earn based on the past history. It's all a number. In the same way, when we talk about a category, suppose I'm gonna get placed in my college or not, I'm gonna do my masters or not. So these are categories in which there will be 0 or 1. That's it. There is two options. So it comes in classification problems. See, based on the problems, the solutions have developed, and we have to understand the solution and implement it to solve a new problem. That's it. This is where the learning and its implementation comes in. Now, the second part of machine learning is basically unsupervised learning. Unsupervised learning is where the input and output comes. There will be no labels, there will be no correct answers of the input. You will just have the inputs. That's it. You have to find the model. Basically, model has to find the hidden patterns and start doing the things. The best example of it is consumer segments. Just like you go and buy something from grocery stores, and you buy the model gets keeps you in a category where you are a very sudden buyer, or you are less spending, you are in the less spending category, and some customers will be in the high spending category. You might be in a category where you visit stores in early in the morning, so you will be in early section. Your Their sales team would be different for you, and the sales team would be different for our evening guys. So these are the customer segmentations. And the another example is anomaly detection, because there's no label data. Label data means where we have the tag of output. See, this is the input and its output is this. That's it. This is the label of that particular data or of that feature. In not unsupervised learning, there will be no labels, only the inputs, that the features that we can give. And in this non is unsupervised learning, the classification, just like classification, there is a new model that we can do or use is um, uh, clustering. We can use clustering in unsupervised learning. And there is one more type, or I think so. This is the very basic bootcamp, so I will not extend this bootcamp or this day from regression to classification. We will cover regression and classification basics. We'll not go to basically clustering and reinforcement learning. See, there's a broad category in this machine learning part is reinforcement learning, where models learn by itself, take decision by itself, but there is a penalty and point model rule, where if a model takes a wrong decision, it will be penalty. The penalty will be imposed on it, like minus 10,000, or it's like a punishment. And if a model takes a good decision and output is very good, it will the points will be rewarded to him. It's just like a game. It's just like a snakes and ladder game. You take a ladder, you go up, or you hit by a snake, you have to come back to your original slide. That's it. So this is reinforcement learning, and nowadays there are many models which are moving forward, or the problems which can be solved using reinforcement learning, and it is very powerful. And although it's powerful, when I talk about powerful, that means it can solve much more complex problems than these two are. So in this session, we'll be covering classification and regression basics, and we'll be seeing how to prepare data for machine learning and how to proceed further with it. Now, we have to prepare data for machine learning models. Before training a model, we must have our features ready and the target, what we have to predict. I'm talking about supervised learning. We have to have the features, the data sets, and then the model's output or the target that we are trying to predict from the model by using the model. And there will be a training set. Basically, consider a data set of we can take a previous example, 70,000, 17,000 rows. It is 100% of data. We'll split it into training and testing set. Training will be 80% of data, and testing will be done on 20% of data. It is a rule of 80-20, where there are many rules like 60-40, 70-30, but the standard is 80-20, because model will train on 80% of the data, and it will be tested or evaluated on 20% of data to see how a model is doing, how good a model is. Simply like that. In deep learning, the same thing we call loss. There is a loss function which we have to minimize it to get the desired results and the proper result that we want. Simple. Now we'll be using scikit-learn library for machine learning part, whatever we are doing, we have to, you have to understand that there are four core libraries in while becoming a data scientist. There is more when we go into deeper into data science part, data engineering part, or deep learning part. There's many libraries, but for the basic, there will be four. First of all, the pandas for working with the data set, basically. Second is Numpy working with numerical values, matrix, and all. And third is like Seaborn or Matplotlib because of the visualization part, we have to visualize each and every data and the feature. And next is sklearn, scikit-learn. It's a very beautiful and powerful library. It has all the models: random forest, decision tree, regression, or sigmoid, or SVM. Every kind of model it has, each and everything. Even the training and testing dataset, splitting of dataset libraries also there. We'll be using that. You will be seeing all this thing by our own and doing it hands-on. And while going forward, we'll be using in this particular day, on last day, Mintis dataset, which is very powerful dataset in terms of our data quality, or training quantity, data quantity and quality both, basically. Basically, it is nothing but a 70,000, nearly 70,000 data points of handwritten digits. It is called MINT's database. Previously, we have used California Housing Database, and today we'll be using that. It is very important and very basic for artificial neural network also, because artificial neural networks are used for recognizing the pattern for handwritten notes of human handwriting. And this data set has the collection of all that images. And for yourself, we have to go the same way. In the folder section in sample data, there is mint, test, and train, which is already splitted, but we will be using that part, and I will show you how to do that, but it has already been trained and split it for you, so you don't have to take care of anything. This is the power of cloud or collab that Google has given us. Now, as I said, it contains 0 to 9 handwritten digits, all the data it has. But for today's ML model, basically, we'll be using it in a more simplified ways. Like each row is a one image. Each row is a one. It is considered to be as one image, or as a one number from 0 to 9, and the first column will be labeled as 0, because in supervised learning there has to be a label. So in a column there will be 0, 1, 2, 3, 4, and each cell will be, or each row will be the data, image data of it, like 0 written in handwritten 0 in a different ways, different format. That's it. There are total 784 something columns, and we will be doing all that data engineering part also. You will be seeing that. Now let's get started, and let's start the coding part. So first of all, as always we do, we will be importing the sklearn library and train, test, split libraries, and regression, uh, basically classification libraries, which will be using logistic regression, will be using for classifying the digits, basically. So I will just import that part. Sklearn dot model selection, sklearn dot model selection, import train, test, split, linear model, import logistic logistic regression. See, there are two logistic regression. First one in which there is no computer vision involved, and second one in which computer vision is involved. Basically, the data is in image form, and we have to take the live data from computer vision or cameras. We'll be using that model for, but but at the basic part, we'll be using simple logistic regression. And from sklearn, we'll be importing the matrices, accuracy score, and confusion matrix. It has given me all this thing. Yeah, confusion matrix, and there's more, but we'll be seeing it later on when we go forward. Now, let's load our data set and see how it looks and perform basic data engineering tasks that we have seen earlier. You can do it by your own, but I'll be start doing that thing right away. Yeah. So I'll just copy the the path. I'll be giving this as this name, read csv td dot. Yeah. Yep. MLDF. It will take some time, but I will just let's just see the head part, the very basic, how it looks like. See now, what it is and how it's looking and how we'll be doing. It is like 000 first of all, but believe me, it's not zero. It is the numbers, handwritten numbers that we say. Now, this is the head section. I've printed all this thing. This is, you can see how the data looks. I know it's confusing for you a bit, but believe me, it is going to be a very much fun uh, coming up this session. Yeah, so I will explaining you what is this data about and how it looks like, why it is looking like 000 and only the first column there are digits. So as I said, it's we are not in using ANN or any convolution neural networks, so we cannot work with actual images, but there are another ways of working with image. I think you know what I'm talking about. We are talking about the pixels. We can play with pixels because all at the end of the day, all the images are converted into pixels, and the pixels are then processed by the machine. So I've put on some details that you can see here. Is basically it's a class is core data frame. You have to see there are 19,000 entries. That means there are 19 nearly 10,000 sorry 20,000 records, which consist the column like this much of column from 6 to 0.6 0.9 5.90, and the memory it is using, you can say it is 90 119 MBs. Now, let's move forward with the describe thing. Here, the things will be getting more clear to you because see, there are count we know there are 19,000 rows, 19,999 rows. Mean is something there's no need of looking at mean because at the end of the day, pixels are in zero to between 0 to 1. So you have to see this medium and max, minimum and maximum. See, the first column that is, it is nothing but the real digits, the labels that you want. Because after that, all these things are converted into pixels. All these things are pixels. There's nothing more than that. But the first column, very first column, is your target, is your label. These all are data, the input that in future we will be giving. But this is your actual output. This is what you are expecting from a machine learning model, that it should understand this thing. So as you can see, the minimum is 0 and maximum is 9 because it's 0 to 9, and the 25% is 2, 50% is 4, 75 is 7, as it is. So this is how you have to describe the data and understand what it is and how it's working, because in this part we cannot do EDA because there is no need because it's a pixel data. You have to understand that also. What type of data I am getting? What is the shape of my basically data set like ML, DF. I will just shape. See, there are 785 column and 19,999 rows. So there we have the sample size of 19,999, and the pixels are the what we can say data points we have are 785 or 84. One is the obviously one data labeled data. So next we will be splitting the data like what is our target and what is our input. We'll be splitting that just now you have understood that first column is our target. So I'll be just uh, I will just put all this thing in a simple way. Well, I will just MLDF. There's a thing of splitting this way. Yeah, yes. This now, if anyone knows what it is, you can write it on in the comment or live section. I'll be reading that, and I will be very happy that you know what is training and splitting all this thing. So what we are doing here is we are taking all the columns in X, which is our input, and Y, which is our target variable. We have to predict the Y using X. That's it. So we'll be transferring all the columns. We'll taking all the columns except one, except the first one in the X, and we'll be taking the first one, not all in the Y. That's it. So let's just take and let's just have a look. X dot shape. Oh, oops. It is. Yeah. See now here we are having 785 columns, but here we have 784 because first column is gone to a Y. So let's see the head part. Now there is no actual labels. Let's see the Y. You have to do the same thing. You have to do the same thing to see all these things. See, there are 19,999 rows, but there is only one column. That's why you are getting zero in the shape. So the first column is here, the label data is here, that's it. We have to do these exact thing. So now we have our uh, target in Y and our training set in X. So we'll be splitting this all thing. Let's move forward with the splitting part. X underscore. It is the basic part, and you'll be doing this whole thing in whole your data science journey and projects that you will be making forward from here. See now what it does, it gives us this thing. Yeah. Let's take 80/20 rule, random state. Let's take 32. That's it. Now, I will explain you what it is and how it's working. So, in Python, there is a rule of stack loading, stack data variable loading. We basically what we do, we write in a sequential way. We write the variable name in a sequential way, and we push on all the inputs of whatever we want to push in the variable in a sequential model, in a sequential manner. So in the same way, train trace split is a function from sklearn, which what it does, it basically takes the for training and target variables and split them into whatever, like I have given 0.2, which is the 20%. The testing size will be 20%, like 80-20 rule that I have told you earlier, and it will be basically splitting it. And the random state, it is up to you how random you want. Basically, you don't want that first 20% will be going to test or first 80% will be going to training. You want it to be randomized because your model will understand more easier way. See, when you start learning your thing, you have an exam in front of you. You start learning things, and when you start with the easy part, and you know when you give the mock test, and you know the exact pattern, and when there's a real exam coming, and you sit in a real exam, you will be getting failed because there's no pattern. There will be randomized things, generalized things, but you have given the mock test, which was already has a fixed pattern. So it was easier for you. You don't have to hustle, or you have to think out of the box to solve that particular problem. So in the same way, we have to train a model in a small child's brain, like how we train a child. Uh, I always say that a small baby is a perfect example of machine learning. If you want to understand machine learning, just sit in front of it, and it will explain all this thing, whatever you want or have. Simple. So this is the training and test splitting part that I was talking about. I will just uh, like it's now created. Now 80% is our training and 20% is our testing. Now X train and X test, we this is what we are going to give to model for training purpose, and we will be testing it to on this with this both data. Like in training, I will be giving train X train, which is our rest of our models data set, and the Y train in the training set or in the training part. And testing, I'll be testing with this. I'll be giving this, and I need this Y test. I am expecting this Y text results from it. That's it. I will be using the prediction on this to understand the actual evaluation models. Well, I am going to evaluate in this Y test. That's it. So understanding it very clearly that X train I'm gonna use and Y train I'm gonna use for model training, and X text I'm gonna use for testing purpose, and whatever will be the prediction I will be using that to compare with Y test and getting the actual evaluation matrix that I was talking about earlier. Now let's just hop in and try to do it. Now, the next thing is building the model, the actual model that I was talking about earlier. I will just declare a variable. Now I will just use that imported logistic regression. Simple. I will give a parameter. Suppose, yeah, max iteration. Yeah, y train model dot fitting. Now I will be just hitting run. See, I have declared a model, I have declared a logistic regression model, and I've given a parameter which is max iteration. It will not iterate like a learning iteration, which would we call it's a cycle basically from more than 1,000. And I'm fitting this model. Basically, I'm first of all I'm creating a blueprint of my model, like what my model will do, how many iteration it will have, and there are different parameters when you go to basically in this like more in depth, it has more models or more parameters, like we can state like random state, max iteration that I'm giving multi-class. If we have more than one class, we can give that also. Class means the labels. If we have different like two more labels we have to predict, so I can give that also. Verbose is basically variability, like how variable my model could be. What are the what we can say tolerance part that I can okay with, like Yeah, there's a 20% tolerance I can expect from my model. There's nothing like that. So I can give that also. You can go through it and you can learn different uh, things, like it is used for classification, because logistic regression is where we predict something, but in here, things are more much in classification way. It gives the output in 0 and 1. It classifies it. That's why it is called logistic regression. And there are many parameters that you can learn in this, but I will just go and hit run for this particular model. And we'll be waiting for this to complete it, and then we'll see what prediction it will make and how my model is performing basically on this data set. Let's see that. Let's wait and watch. Now, as you can see, my model has been executed and it has already been trained on the data sets that I have given, and it is almost taken 2 minutes to run basically. So this is the model name. You can also see on your screens also, if you are doing hands-on, it is logistic regression and its max iteration is 1,000. Basically, it's a cycle to learn upon. Now let's just go into deeper about prediction. Let's uh, predict something using this model. So I will be using bread and this model. I can also create like different types of model, like model 1, 2, 3, 4, 5, 6, with be using different model names, like logistic regression, random forest, decision trees, when I'm talking about classification, and there are SVM I can use. So it's a same way, like hit and trial part, like which model suits my on my data set well. So I'll be doing, you can also do at the same pace. Predict our X test. Now, as I said earlier, while I was splitting my data sets, is that this X train and Y train I will be giving to model that I have already given it. Now, X test I will be using for testing purpose to see how my model predicts and what my model predicts. Now, let's just predict this model. Yeah. Now let's see Y pred. Led bread. Let's shape. There's no. Oh, no shape. Shape. Yeah, 4,000. As I said, it's a test. So now let's just head five. Let's see the first five thing. Mm, I think so. Yeah, it's not. Yep. Now you see why I was getting that error, because y pred is an array, is an simple array. It is predicted in an array form. The what data I have given, like what pixel values I have given, it has predicted its actual values like 4, 9, 3, and not more than that. That's it. Now let's check the accuracy of my model. Hope so. It is good. Uh, as I said, I have used X train and Y train for training. I've used X test for prediction, and I will be using Y test, the actual values versus the predicted values of my model using ypred. So you have to take this very carefully, where you will be using X train and Y train, where will you will be using X test and where you will be using Y test. That's it. So I'll be just uh, accuracy. Let's see. Yeah, okay. So yeah, it has performed better. I can say it's not the best performance of my model, but it has performed better, not the best. Simply, it has got 84 something accuracy score, which is like 84%. Not bad, not good. It's an average, but we can obviously it can be gotten better if I have given much more clear parameters, or the training set, or the like data set that I have provided him. I have just shown you what are the steps to train a model and check its accuracy. Now, there are many accuracies or like validation matrix that you can use. Next, the mainly and very important in classification, it is confusion matrix. Confusion matrix is nothing but a matrix where you will be just like this. Confusion matrix. Yeah. Yep, you can see here it is actual positive, actual negative, predictive positive, predictive negative. Now, what it is, I will explain you in deep, like what is confusion matrix is. So, actual positive is what the actually it is like our in our case it is x y test. Actual negative, like what not it is like the actual thing, the real thing that my data set already has, the labeled data. And predictive positive is how many points or the sets that my model has predicted correct. Suppose I'm having a 10 data points in which 5 was like true and 5 was false, but my model has predicted 4 true and 6 false. So the 4 will be coming in this first particular cell, and the rest will be coming. Suppose it has predicted like all this other like remaining 5 false that already my dataset has correct. So it will be coming in true negative, predictive negative, and it was also a negative. Now, there are two types of error when we talk about confusion matrix. The first type is false negative, and the second is false positive. Suppose you are having a cancer, but you have a data scientist has developed a model which is predicting that these guys or this guy doesn't have the cancer. How? See how the situation is very severe. You are having that problem, you are having that disease, but model is saying you don't have. So it is actually a type of error that we say usually is this first type of error. And it is very, very crucial and very dangerous, I can say, because it is actually a positive, but your model is telling it is negative. So it is not negotiable simply because you cannot negotiate this error. You cannot negotiate that a person has a cancer, but your model is saying no, and you are negotiating with it. No, this will not be the case. The second type of error is where you can negotiate somewhere because your model is like actually it is no, but your model is telling yes. Although you can validate it, like my model, a machine learning model is telling that you have the cancer, but you don't have it. So it's a negotiable part, but the first type of error is very crucial and very dangerous, false negative. So you have to understand these things, and you have to understand how the confusion matrix works. Go and search, sit quietly and understand all these things. Actually positive, actually negative, predictive positive, and predictive negative. This is the prediction, your model prediction. This is the actual data set, the test part. Why test? This is what it is, and you have to correlate them. And this is there are two type of error: type 1, type 2. Type 1 is very, very dangerous and very complex. You have to take care of it. And the next one is type 2 error, that where things are negotiable, or you can ignore it kind of part. But it will be much better if you like have the attention there also. So this was about uh, confusion matrix, we will be doing like making a confusion matrix also. Let's just start that. I will not use matplotlib here. Let's use Seaborn because it is also important for you. Seaborn SN. Yes, I've imported it. It will take some time. Yeah, that is already done. Mm, I've already imported that confusion matrix. Now I will just plot that. I will just plot that thing. SNS heat map to FT. Yes. Now I will do one thing. I will just write this also. The figure size. Yeah, figure size is also done. Now, as you can see, the confusion matrix, I have given the actual text test y test, which was the correct part, the actual positive and negatives, and the y pred, like y pred, the predictive positive and negative. This all comes into a matrix and it will show me in such a way. Yeah, let's just run it and yeah, I think so. It's done. Yes. Now, yeah, the confusion matrix has already been like plotted. So, see how to read this confusion matrix. See, when we saw this confusion matrix, it was much simpler. But when we do it in with a real world problem or with the real world data set, it's more complex. So that was the conceptual diagram of confusion matrix when there is actual and predictive, but here also it is same, just you have to see in the way. See, there's first of all this heat map, it is a heat map, and this line, this what we can say, markers are like 400, like very good and very positively predicted, or the very good part, zero is very negative, the wrongly predicted. Yeah. So just see, like just take an example like zero. For zero, my model has predicted 388 trues. Like zero, it has told zero to be a zero. When it saw a zero, it told that it is a zero, and when it saw like one, it told zero how many times? Zero. Like it's like it's a count basically. These numbers are counts. These are the actual values, like 0 1 2 3 4 5 6 7 8 9, and these are the predicted values like my model has predicted. Now when I say actual zero, my model has predicted also 388 times. Actual one, my model has never predicted actual one. Like when it has seen one, it has never told like it is a zero. My model has seen two, it has told four times that it is a zero. My models have seen three, it has said zero times that it is a zero. My model has seen four, and it has told two times that it is the zero. So it is a false, basically false prediction. In the same way, when my model has seen 1, it has told 414 times that, yeah, it's a 1, it's a yes. Now, my model has seen 2 and it has told like 332 times that it is a very correct, it's a 2. In the same way, you will see, there is a pattern also here. When you talk about like nearby values like this and this, see 441, 12, 332, 16. So my model has seen 3, the actual 3. It has predicted 16 times that, yeah, it's a 2, but it was a false prediction. That's it. In the same way, when my model has seen 3, actual 3, it has predicted 24 times like it was 2. It's in a simple way. In the same way, all this thing is right here. Like when it's a 400 times, it was very good that my model was predicting much better. Like here, you can see 27. When my model has seen 4, it has 27 times predicted that it is 9 because 9 and 4 resemble in a way. So my model got confused there. When it has seen 7, it has predicted 30 times that it is 9. This is how you see a confusion matrix. You have the better understanding of what actually your model is doing, how accurately it is predicting that particular point. So you will evaluate your model. This is the way you evaluate your model. You obviously you will train a different model and see how accurate it is. The next part in this is validation. You will have a different data set and you will validate once more. Then there's a part where the hyperparameter tuning comes, where you tweak the parameters of it, like instead of 1,000, you give 2,000 or 50, whatever it is. It's a at the starting of this session, I told you that it's a hit and trial thing, training a model and getting the best accuracy out of it. In the same way, the same pattern goes on. In the same way, you train a model, you basically take a data set, you test it. You first of all, you take a data set, you split it in a training and testing sets in a randomized manner. You take a model, you basically build a model and you fit it on your training set. Then you take like the next part, that you try to predict the values that your model gonna predict using the test sets. And after taking that prediction, take that prediction and like calculate the accuracy score. After that, try to bring with the different evaluation metrics like F1 scores, the recall, the precision, how precise your model is, or how recall is means how your model is recalling your the previous patterns, or the confusion matrix when it comes to classification problem. That's it. This is how you do your data science stuffs or make machine learning models. This is how simple it is.